Hello! Welcome to Homework Help 7.2. Sorry this video was a little bit late. I was having printer issues. This is just the day for technology problems. So, number 5. Zoom in a little bit more, number 5. Boop, boop, boop. The way. So, construct a parallelogram given sides xy, xy, and yz, and this angle. Okay. So, our first step. So basically, what do we need to find? We need to find a side over here that is both parallel and equal to this side. All right, our first step, I wish this was a little bit bigger. Maybe I should draw it instead. It'll be fine. Is we're going to draw the arc. So I'm going to put my pointy end on point Y, and I'm going to put my other end on Z. Yeah, there. It's a little, and I'm going to draw an arc. If my compass would cooperate, that'd be ideal. There we go. Maybe. Why are you just... Okay, I'll hold you there. And we're going to draw an arc. Okay. There we go. So that was the first step. Okay, now, really I guess you could have done this one first. It doesn't matter which one you do first between these two. I'm going to copy the length of xy because this other side is going to be the same length. Okay, so using your compass, I'm going to put my pointy end on y. It should be there already, and my other one is on z. Can we see that okay? Yes. Okay, I'm going to copy that length onto x. So pointy end goes on x, and I'm going to draw an arc. See if it cooperates with me. We're good. Oh yeah, we're good. Okay. There we go. Oops. There we go. Okay, so now, every point on this arc that I just drew is an equal distance from x. So like this point that I'm on right now is some distance from x. This point is the same distance. All the points on this arc are the same distance from x. Are you with me? So if I was only worried about length of this side, I could draw my line anywhere on this arc. But I'm worried about length, which I've taken care of with this arc, but I'm also worried about it being parallel. It has to be parallel to this side as well. Okay, don't just estimate like I just did. That's not how you're going to do it. So what you're going to do the parallel is we're going to copy this arc. Oh, I could label this. Does that help? I like to label my points. Let's make that W. There we go. So I'm going to measure from X, from Z to W. I'm going to measure my arc. Should be pretty close. Okay. Oh, we need to extend this line out just a little bit. Where's my straight edge? Uh-oh. Hold on. Sorry, I forgot to resume. So all I did with my straight edge was I need my YX line. I mean, if you can see it, then you can see it. But I need to know the point. So I just extended my XY line and got a new point right here. Yeah, T. Sure. Okay. So I did my arc. So now I'm going to oh, okay. So I'm copying my arc size. Copying my arc size. The pointy end goes on T. And then we're gonna, it moved, hold on. There we go. So once again, your point of intersection is the key. We'll make that X. Oh, we already have an X. Awkward. Now I'm stuck on X. We'll make it a sideways L because I don't know. Anyways, now you have your last vertex. So now you can just connect your points. So I'm going to connect Z to L. And I'm connecting, we only needed T to make that last point, to make that last intersection, okay? It's not actually one of our vertices. So I'm going to connect L to X. And there you have a parallelogram. So your top is parallel to your bottom, and your sides are parallel. Okay. Number 6, construct a line parallel to QT and through point R. So you're given a line QT and you're given a point R, and we are going to make a parallel. Okay. So if you don't, oh, never mind. Actually, it's fine. Never mind. Well, yeah, if you're doing this on a separate sheet of paper instead of printing out the homework, then just make sure I would use a straight edge to just make sure this line is straight, right? It's not all wonky tonky. I don't know. And then put a point somewhere up there. Okay. So here we go. Construct a line parallel to QT and through the point R. The first thing I'm going to do is, using my pencil and my straight edge, is I'm going to connect Q to R. Okay, I'm going to connect these two dots, these 2 points, with a line. There we are. So what happens when I do that is I create an angle. So now I have created some angle. Right? I drew a line and I created an angle by connecting Q to R. I created this angle right here. Okay. For lines to be parallel, they're going to create the same angle. So QT with QR creates this angle. So my new line that's going to go somewhere here has to create the same angle to be parallel. In order to be parallel, they have to create the same angle. So what I'm going to do is erase my little dots that I just put on there. So I'm going to start out just like we would with the parallelogram by putting my pointy end on Q and this some distance away. Okay, I'm going to draw an arc. Here is my original angle mark. While were you? I can get rid of it. That was just to show you that we created an angle. Right? It had no other significance. All right, so I created an arc. Once again, I did that by putting my pointy end on Q, and then I just went some distance away. I didn't measure it. Again, I just created that arc. Okay, so go ahead, and what we're going to do is, where'd I go? Oh, we're going to copy this angle. So I was here, and I made an arc, and we're going to copy this angle onto point R. So put your pointy end, keep your compass the same. Put your pointy end on R, and we're going to draw another arc. Oh no, I moved. Hold on. Stay. Okay, that should be plenty. All right. There we go. But now I need to know, once again, my problem becomes, where on this arc am I going to draw my parallel line? Okay, I'm not done yet. I need to know where along the arc I'm going to draw in my line. My bad. Before I move on, I'm actually going to extend my line so it goes through my arc. So just extend with your straight edge this line. There we go. So it goes through your arc. My bad. Need to draw that longer when we started. Now, we're going to measure this arc. So pointing in here. So you're measuring where it intersects. So it intersects here to here. That's where it crosses. So there to a little bit into there. So we're measuring that arc. So what you're going to do, you measure this arc. So go ahead and put your point in on our new point. Let me label it, I don't know, R. No, we already have an R. I keep doing that. P. There. P. Hold on, let me make sure I didn't lose my measurement with my compass. Oh, we're good. So then from point P, I'm going to draw that same, oops, hold on, it's going to move on me. There we are. Okay, and it is that intersection point that you're going to draw your line through. There. Oops. Ta-da! All right, so that is how you do number 6. Number 7, we did an equilateral triangle at the beginning of class. So do the equilateral triangle on your own. And then, I don't want you to mess with number 8. If you're dying to, I suppose you can, but you don't need to. All right, the other ones, this is review. You have 9 through 11. You are creating explicit and recursive rules/equations. Okay? So it says, for number 9, find an explicit function rule and a recursive rule for the dots in step n. So from step 1 to step 2 to step 3 and so on and so forth, what are we doing in this pattern? Okay, well, let's see. How many dots do I start out with? I start out with 1, 2, 3, 4, 5, 6. I start out with 6 dots. Yeah, I'll do it in 10. That's fine. 6. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I have 11 dots. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then I have 16 dots. Okay? So pause me for a second. Oh, never mind. Yeah, pause me for a second. What are we doing? Every time. I'm going from 6 to 1 to 16. So what am I doing? Am I adding? Am I subtracting? Am I multiplying? Am I dividing? Well, let's see. From 6 to 11, I can't think of an easy way to multiply that. So let's see. If I add 6 plus 5 is 11. Okay. Let's see if it works again. 11 plus 5 is 16. All right. So that is my rule. I am adding 5. So for recursive, you always want to identify where you start. So f of 1 is 6. So you just want to identify that. And then f of n equals recursive. So you have, there we go, f of n minus 1. This just means previous term. This means previous term. So what are we doing from the previous term to get to the next term? So what did I do from 6 to get to 11? I added 5 plus 5. Okay, that is the recursive rule for number 9. Okay. So remember recursive, your equation, yeah, okay. Your equation for recursive is f of n. If you do f of x, it's fine, equals f of n minus 1, and then whatever the pattern is. So if you're adding, then it's like, so plus or minus the common difference. If you're multiplying or dividing, then you would be multiplying or dividing by d. Okay. Recursive, no, we did recursive. Explicit function. Okay. So explicit function, explicit. So is this linear or exponential? Are we adding or multiplying / dividing? We are adding. Okay, it is linear. We are adding the same amount on each time. That means I want your brains to go to this equation. Y equals mx plus b. Oh, you can't see it. Y equals mx plus b. Let me zoom out a little bit. Okay, that's probably fine. All right. So, what is our slope? What is our rate of change? What is m? 5. Okay, and then if you're using this equation, you would want to find your y-intercept. So this is step 1 means x equals 1, step 2, x equals 2, step 3, x equals 3. So x equals 0. So if x is equal to 0, how many little dots would I have? You have to do the pattern backwards. If x equals 0, how many little dots? From x equals 1 to 2, I'm adding 5. From 2 to 3, I'm adding 5. So what would x equals 0 be? You would do your pattern backwards, so you would be subtracting 5. Okay, so there would only be 1 dot. 6 minus 5 is 1. Okay, that fits our pattern. 1 plus 5 is 6. 6 plus 5 is 11, and so on. All right? If you wrote it in point slope form, that's fine. I'll take it. That would be something like y equals, your slope would still be 5. Sorry. Your slope would still be 5. But then you can choose any of these points to put in. So you can do 1 and 6, 2 and 11, 3 and 16. Generally, we did 1 and 6, the first one. So let's do x minus 1 plus 6. Also fine. You could easily turn this equation into this. Oh, sorry. You can. These two equations are equal to each other. I could solve this equation to get this equation. So really, either answer is fine. I generally prefer this one. It makes me happier. So that's what you're doing for 10 and 11 as well. You are going to run into an exponent. Oh, through 13. Oh, shoot. I need to go change your assignment. Ha! I thought, okay. Well, bummer. We need to do through 13. Okay. Well, that's what you're doing for the rest of them. And some of them will be exponential. In fact, number 10, 12, and 13 are all exponential. Good luck.